also take a small sample. And in that small sample, we'll have data on both the auxiliary variable and the variable of interest, x and y. Now, the reason I kept saying sort of two samples, that's how it's specified here. Usually the small sample is a proper subset of the large sample. That is, it's a subsample of the large sample. Doesn't have to be, but usually that's the convenient way to implement it. Okay?
No.
No?
Oh, you're going to press to the next slide. Don't do that.
Here goes Jonathan. Question back there? Or?
Yeah, does that affect the accuracy at all if it's a subset or not?
It does. It does. We are going to end up, great point, and it's the point I sort of finished on last time. In the end, using this approach, we're going to observe fewer sample units for Y. Okay? But we will make up for that by capitalizing on the relationship between X and Y. And we have X on a lot of units. So, examples. Ownership-wide forest inventory update. Any sizable land management agency is managing forest land, they'd like to have up-to-date information on their current standing volume. But if they're of any size at all, they can't do an inventory every year. It's impossible. Well, it's not impossible, but it's cost prohibitive. Can't do it. So what people tend to do, or what some people tend to do, it's all over the map what people do. But what some people tend to do is every year they take and observe some portion of their ownership for current standing volume. So they'll have current standing volume on a subset of their ownership. But they have a previous standing volume estimate, presumably, for their whole ownership. Or maybe for some larger fraction, they have standing volume within the last 5 years. So they can use that information as an auxiliary variable in their current this year inventory as their variable of interest. So that's a common approach to, that is this double sampling idea, is a common approach used to update forest inventories. Ownership-wide forest inventories. Here are a couple of examples, though, of where we said, well, we could use regression ratio estimation in this situation. And no one challenged me. Don't want to challenge the professor, right? But of course, it really didn't make any sense. Once you learned that we had to know the true mean or true total of X. So, for example, volume per acre and remotely sensed volume, we said we could use a regression ratio estimator. And that's true if we're using satellite imagery or something that gives us complete coverage, right? Then we would have this auxiliary variable for the whole area. But oftentimes we take this approach with aerial photography rather than satellite imagery where we have wall-to-wall coverage. Right? And typically we will not have wall-to-wall coverage, or will we want to interpret wall-to-wall coverage using aerial photography. So more often than not, this on-the-ground volume versus remotely sensed volume, with the exception of satellite imagery, or maybe LiDAR, is done with photography, and we just have a bunch of photos, but we don't have complete coverage with the photos. The other example I used was the urban situation, where we were interested in estimating cost of removing damaged trees or whatever. I said, well, yeah, this looks like a case, because cost is related to size, looks like a case where we could use regression ratio estimation. Well, yeah, we could use regression ratio estimation if we knew whatever this size was that we used as our auxiliary variable for all the trees, right? But maybe we won't know that. Instead, we could sample, take a large sample of trees for size, and for a subset of those, get some estimate of cost. So it really is making what we talked about, several examples we talked about under regression ratio estimation, more realistically applicable. The other one that we'll get to later, just because I like to look ahead a little bit at times, and relate this to something that those of you who have some field experience should be able to understand. The other place we're going to use this double sampling idea is in just straight up timber cruising for a sale, timber sale for example, or a stand exam, if we're interested in just a very one well-defined area. And if we're using what I'll call variable radius plots, or what you might know of as prism cruising or angle count cruising or whatever, to estimate volume, the most effective way to do that is to use double sampling. We're interested in volume per acre, right? That means we're going to have to measure a bunch of things on these trees, on our plots, right? We're going to have to measure diameter, probably height, observe species, maybe some other things, to get an estimate of the volume of that tree. And that's expensive, right? Got to walk to the trees, wrap tapes around them, and so forth. So I would ask you, field experienced foresters, what variable might I use as an auxiliary variable in that case? Remember, the variable of interest is volume per acre. What variable might I use as an auxiliary variable in that case that is really cheap to obtain when I'm using variable radius plots, prism plots, angle count plots?
Basal area.
Someone said?
Basal area.
Basal area. What do you have to measure on trees to get basal area with angle count plots? What do you have to measure on a tree? Nothing, no, nothing. You don't have to measure anything. You just count trees.
On the variable radius.
Variable radius
It's
plots.
fixed, and if it's in or out.
Yeah, that's it. That's all you need to know. Isn't that a lot easier than taking all those measurements? Absolutely. So we'll come back to that one. Everybody get the idea? Okay, so much for the fun. What's small n always? Sample size. Now we have 2. So we need to subscript it. N1 will be our large sample size. N2 will be that small, usually subset sample size. So phase 1 is the large sample, N1. Phase 2 is the small sample, N2. So on N1, we will have only information about the auxiliary variable. On N2, we will have information on both the auxiliary and the variable of interest. Cap N, no different. Total number of units in the population. The units are the same, right? We're just taking a bunch of them in one case and a smaller number of them in the second case. But the units are always the same. So there's only one cap N, total number of units in the population.
So the cap N be your N1 plus your N2?
No. N, small n, is sample size. Cap N is population size.
Oh, yeah, that's right.
X bar, mean of the auxiliary variable. Right? The label we use for the auxiliary variable is X. But we got two of them. One from the first phase, one from the second phase. And so again, we subscript them based on the phase that gave rise to them. And finally, Y bar. Well, it's really Y bar 2. But is there a Y bar 1? No, we didn't observe Y on the N1 units. So typically we drop the 2 subscript because there's only one Y bar. It's only on the second phase. We will use the second phase units, the units on which we have both X and Y, to, for example, estimate the slope for the regression estimator. It's all we got, right? We can't do anything else. Those are the only units that we have, XY pairs. So they're the only units we can use to estimate the slope of the relationship between Y and X. Also remember, for ratio estimation, the standard error formula had a covariance term in it. It still will. And the only units we can calculate a covariance for are the N2 units. So most of the calculations will be done using that subsample N2. Schematically, this is a handout. Hopefully this will make it obvious if it's not already obvious. Every one of these